Welcome to Brain Vision.
We're going to let counterclockwise be positive, and we can say that tau sub u, the torque sub u, would be the torque due to the net force. We can say net force of water on the upper half of the gate. We can then say that E sub, or rather tau sub L, would be equal to the torque we can say due to net force of water on the lower half of gate. So we can also let h be the height of the gate. And so we can say that then in order to, for the gate, we need to calculate the torque due to the force on a narrow strip of height dy located a distance y below the top of the gate, then integrate in order to get the total torque. So the net force on the upper strip of the gate, essentially, we could say dF would be equal to the pressure times y times change in area, where pressure in terms, not pressure times y, pressure in terms of y, the pressure in terms of y would be equal to the density times the acceleration due to gravity times y. And we can then say also that change in area would be the weight times dy, the width times dy, with the width equaling 4.00 meters. And we can then rewrite all of this and say that dF would be equaling the density times g times y times the width w times dy. And so we can then say for the moment arm is going to be h over 2 minus y. And so the torque d tau would be equaling the density times the gravity times the width, h over 2 minus y multiplied by y dy. And so the tau of the upper half of the gate, the torque on the upper half of the gate, would be integrated from 0 to h over 2 times d tau. This is equal to the density times the acceleration due to gravity times the width times the integral from 0 to h over 2 multiplied by h over 2 minus y multiplied by y dy. And so this is going to be equaling density g, w width, and this would be h over 4 multiplied by y squared minus y cubed divided by 3, evaluated at 0 and at h over 2. And so this is going to be equaling density g with h cubed over 16 minus h cubed over 64. And the upper half, the torque on the upper half would be equaling density g width times h cubed over 48. And we can calculate 1,000 kilograms per cubic meter times 9.80 meters per second squared multiplied by the width of 4.00 meters multiplied by 2.00 meters, the height of the gate, cubed divided by 48. And we find that the torque on the upper half would be equaling 6,533 approximately Newton meters. So take note of this torque. And now we do the exact same thing, but to the lower half of the gate. And we're going to be then saying that tau sub L, this would be, again, essentially the exact same thing. However, here now, you consider a the narrow strip on the lower half, but now the depth of the strip is not h over 2. We said h over 2 minus y. This is h over 2 plus y. So the exact same thing, however, we just changed the sign. And so we can then say that tau on the lower half would be integral from 0 to h over 2 multiplied, of the density g with h over 2 plus y times y dy. This is going to equal the density times g times the width times the integral from 0 to h over 2 of, again, h over 2 plus y dy. And the torque on the lower half would be equaling the density times the acceleration due to gravity times the width multiplied by h over 4 times y squared plus y cubed over 3, evaluated at again 0 and h over 2. This is giving us rho g w h cubed over 16, and now plus h cubed over 24. This is giving us rho g w h, rather 5h cubed over 48. And now we can solve. Again, 1,000 kilograms per cubic meter multiplied by 9.80 meters per second squared multiplied by the width of 4.00 meters, lose the units, multiplied by 5 times 2.00, the height, 2.00 meters, the height of the gate quantity cubed, divided by 48. And this is giving us 3,267 Newton meters. Now, then the total torque, we can say tau would be the torque on the lower half minus the torque on the upper half, and that would be according to the sign conventions. This is giving us my apologies. I said 3,267. It's actually 32,670. My apologies. I read. And so we can then say that here, for the total torque, we have 32,670 minus 6,533. This is giving us approximately 2.61 times 10 to the 4th Newton meters. This would be our total torque. And again, it's positive, so we have a counterclockwise rotation. That is the end of the solution. Thank you for watching.